Hi everyone. So we are here to answer a simple question, and that question is it safe to run applications in Linux containers? So initially I wanted to go for a simple answer, yes, let's go have lunch, it's done. And then suddenly this happened. A few weeks ago, someone came up with an exploit allowing anyone to break out of a container with Docker. So suddenly I decided to revise my answer and say, no, it's not safe anymore. But let's investigate a little bit to see exactly how safe or unsafe it actually is. So first, why am I here and who am I? So I'm Jérôme Petazzoni. I have a thick French accent. And before Docker was cool, it was .cloud. So I'm kind of a Docker hipster. And .cloud was operating platform as a service. And we were hosting people's code. And I'm like crossing fingers and knocking on wood, but in 3 years, we didn't have a major embarrassing security issue. We hope that will continue. And we were using containers, so some people thought that we were qualified to talk about containers and security. I will let you to judge that. So first, a little refresher about containers exactly. So what are containers? Containers, a good technical approach is to think about it like a chroot jail. So you run some processes in an isolated file system, except that containers add some extra isolation features. So you have your own network interface, and you have your own process tree, so you can see the processes running on the machine and in other containers. And you have control groups, which lets you measure and limit the amount of RAM and CPU and disk I/O that you're using, so that if one single container suddenly goes crazy, it won't bring down the whole machine by using up all the resources. You can also think about containers like lightweight virtual machines because you can SSH into it, you can have root access, you can apt-get install stuff, you can set up IP tables rules, do anything you like, mount file systems, and so on and so forth. And the reason why containers are kind of trending now is because they are seen as lightweight, fast, throwaway virtual machines. They boot extremely fast because you don't have to boot a real kernel. You don't have to set up virtual hardware and all that stuff. You just fire the process that you want to run, and that's it. So that gets lots of people really excited. And so the thing is that if you are familiar with containers, you may think, well, those things have been around for years, even decades, like user mode Linux and vServer, that was more than 10 years ago. Then there was OpenVZ, and then even LXC is a few years old. So why suddenly so many people are getting excited about containers? I'm going to blame the whale because, well, Docker made it super easy to run containers, and so suddenly, instead of being like the secret weapon of some black belt DevOps ninja, containers become something that everybody can use, and therefore getting them to be secure became kind of important, you know. There is another talk about containers and production issues and everything this afternoon. There is also Docker office hours tomorrow and a meetup at New Relic tomorrow evening. See if you're excited about containers. So when trying to answer the question, is it safe to run application in containers, I tried to fish in ancient wisdom. So Dan Berenger is one of the authors of the initial LXC tools, and he said that LXC is not yet secure. If I want real security, I will use KVM. So I will use a virtual machine. The thing that gets me excited in that quote is not secure, it's yet. Because he said that 3 years ago, and while it's still partly true, the kernel changed quite a bit in 3 years, and things got better. Then if you ask on Reddit, which as everybody knows is like the universal source for truth, wisdom, and everything, people will tell you that LXC suck and shouldn't be used for security isolation. And that's a common opinion among security experts, and I can't blame them because if they go to tell their boss, yeah, boss, LXC containers are secure, let's deploy everything on LXC, and they're not, they might lose their job, so they'd rather be careful about that. Something interesting, and we will get back to that in a couple of slides. If you have root on a container, you have root on the whole box. It's not completely true. I wouldn't go as far as telling that it's completely false. It can be true, but we can also make that false, and it's also misleading. We'll see why in a couple of slides. Then Dan Walsh is like SE Linux guru. If there is anything about SE Linux, he knows it, and he said containers do not contain. I was at a talk he gave a few months ago, and he got the whole audience to stand up and repeat after him, containers do not contain. So I will not do that now. My idea is that containers sometimes do not contain, but we will try to get them to be more contentful, maybe, and a little bit more secure. And then I found another quote in an old VAX VMS internal data structures book speaking about the castle of Minas Tirith, which is something in the Middle-earth, in the Tolkien books, actually. So it's a quote in a VMS internal book speaking about Tolkien. And the interesting part is that it talks about the castle, and there are 7 hills on top of each other, and in each hill you have a wall, and each wall you have a gate. And the thing that is inspiring here is levels. So security is not in and out. You have a number of walls and things, and you're not like suddenly breaking into the core of the fortress. You have multiple layers to go through. For instance, let's look again at if you have root on a container, you have root on the whole box. Even if that were always true, why the hell would you give people root access in a container? I mean, if you're like a VPS hosting provider and you're doing like PHP stuff, you won't give root access to all your customers. You will give them something else so they can upload their code or push it with Git or whatever, but you won't give them root access because that would be highly insecure. So that's the kind of the same idea. First, we will see that not giving root is a good way to make a lot of improvements in the security of containers, and that if we really have to give root because something wants root access for some reason, we can give something that looks like root to make those processes happy. And really, if we have to give away the root privileges, we will see how we can add an extra safety wall around the container. So this is an illustration of that castle I was talking about earlier. So root on the machine is the little tower on the top, and the evil intruders are outside. And of course, if you assume that from start they are kind of magically paratrooped in the middle of the castle, they are in a much better position to attack the castle than if they start outside. But before thinking about how are we going to prevent them from going from the 3rd level to the 7th level? We will think about how can we keep them out of the place in the first, because that's just easier. So there are not only just one kind of applications, there are many different kinds of applications, and for each different kind of workload that we want to run in containers, we will have different threat models. So we will talk about regular applications, like 99% of the stuff you run, web servers, databases, and so on and so forth. Then system services, and I decided to arbitrarily break that down between logging and remote access and cron, that kind of things, and more like lower level things like managing the devices, setting up IP address, like low-level management. And then there is the stuff that needs to run inside the kernel, so the actual drivers, all the things about managing the security in the system. And I will wrap up with a little word about immutable infrastructure. So normal applications, so most of the workloads you will ever want to run in containers. So that's really any kind of code, anything, as long as it runs on a Linux machine. This is a normal application. Most of the time, you just don't need root. Like if you run a database, you don't need root. If you run any kind of web service, web app, or website, anything, there is no valid reason ever to have root. So don't run things as root, period. So let's see what can happen to that kind of container. First problem, what if people run arbitrary code? Are we in trouble? Well, the thing is that by definition, we want to let people run arbitrary code. If you are a hosting provider, you want people to be able to run arbitrary things because that's the service that you provide. So there is nothing specific to do about it. Just let people run arbitrary code and just be aware that if they are malicious, they will try everything they can to get out of the container. Now, let's see. we said don't run anything as root. So the risk is we have some non-root thing and it escalates to root. And there are many ways, unfortunately, to achieve that. So let's look at a few of those ways. One way is to find a bug in some setuid binary like ping or sudo and to exploit that. So an easy solution is to get rid of the setuid binaries because most of the applications out there don't need them. You might need them for debugging, like ping, but during the normal operation of your database, you don't need ping. So get rid of all the setuid stuff. Then another risk is what if there is some bug in a system call and there is some parameter that it's not correctly checked or something like that, and someone finds a way to put together some funky parameters from that syscall and boom, they get to the kernel to execute arbitrary code. Then you are in big trouble because containers share the same kernel. There is one kernel on the machine and that kernel runs all the processes outside the containers, the processes inside the container. And so that kernel can access everything. So if you can get that kernel to execute arbitrary code, you're expletive deleted. So the idea here to avoid that issue is to work on those system calls. So there are multiple ways to do that. There is something called secure compute, which lets you define some kind of filters, whitelist, blacklist of allowed system calls. So you can lock down all the exotic new fancy stuff. You can also run stronger kernels. Like JR security is a great kernel if you want some extra security. And there are some really good news. Just while everybody was enjoying the July the 4th fireworks, the JR security team announced that they would start supporting kernel 3.14. And why is that a big deal? Well, because the previous stable kernel was 3.2. And kernel 3.2 doesn't work too well with containers. Actually, anything before 3.8 won't work very well. There will be corner cases, race conditions, things like that. So if you backport, if you cherry pick and backport all the necessary patches, you can run with an older kernel. But that wasn't the case of the old 3.2 JRSec patch set. So now we can again have JRSec and containers together, and that's great from a security point of view. Something else also is to be able to roll out new kernels easily. It's not just only about, if you are able to upload your kernel every week, that's great and it's fine. But a better thing is to be able to upgrade quickly if necessary. Because if there is some embarrassing exploit like the VM splice thing from 6 years ago, you want to be able to roll out new kernels almost instantly. You don't want to wait next week. So it kind of sounds a little bit obvious, but make sure that you can upgrade your stuff, because if you need to, you will be able to do it quickly. So another thing that we're worried about is UID leaks. So let's say that there is some bug in the containers code and you make a syscall and you find a way to kind of hop to a different container. Like, I don't know, let's imagine that you make an open syscall with something weird and you end up opening something that is in another container. Then if you run as non-root, like let's say your UID 1000, you might be able to get access to the files of another container that would also be running as UID 1000. So to work around that, there are a couple of solutions. You could make sure that you allocate different IDs, but that's a little bit cumbersome. So you can also use something called user namespaces that lets you map UIDs. So you can have a given UID inside the container, and that maps to a different UID outside the container. So that unique mapping will be done at this level outside of the container. There is another way. There are security modules like SELinux lets you define security context and tag and label resources appropriately. So if you were a little bit crazy but wanted to gain a lot of SELinux experience, you could run everything as the same user, but using all the SELinux features, make sure that the Apache process can only access the web files and the web logs, but cannot access like the mail queue and stuff like that, even though the mail server runs with the same UID. Don't do that, but it's to explain that you can isolate stuff with SELinux or AppArmor or another security module. and it's a good way also to avoid that. So let's look at the system services, so the thing that almost everybody runs on every single machine and that you might want to run in your containers, so cron, SSH, syslog. Bad news, typically those things run as root. They will eventually drop privileges and things like that, but still they run as root. The thing is that they don't really need to run as root. If you have an SSH server and multiple users, you need that SSH server to be root so that it can drop to the specific user that you want to log as. But if you have a machine, in that case a container, and one single user in it, why couldn't SSH run as this user, the SSH server, I mean? So when you log in, you're immediately as this user. There is no user transition, so you're not root, so there is no risk of, I found an interesting bug in SSH, so I'm going to own all your machines. So the thing is that most of those services generally don't want to run as non-root. They will eventually drop privileges and use other mechanisms to make sure that they are not completely insecure, but still. Good news anyway, they are not arbitrary code. So you end up running something as root, but it's not random code uploaded by your users. It's something like cron, syslog haven't moved in years. SSH is something that everybody in the security community looks at, so it's not so bad. What happens if there is a bug anyway? Like, we found, again, an exotic thing. If you put some UTF-8 emoji characters in a cron tab, cron goes crazy and you can execute random stuff. So to avoid that, there are a couple of things. First, I would isolate sensitive services on separate machines so that if someone breaks into them, they only break into that environment and not into all the containers. So for instance, you could have SSH on a separate machine and then bounce from that machine to your containers. Even though, to be honest, if someone can break into your SSH server, you will be in big trouble, and containers are not containers, that won't change anything about it. What if those people, so if you run like SSH, cron, syslog in a container and someone still finds a way to exploit them and to run arbitrary code. Maybe they could access things in /dev. They could go straight to /dev/SDA and mess up with the file system and things like that. So containers have the device control group. A devices control group lets you define like a fine-grained access control to allow or prevent access on a major or minor or device number basis. So you can deny everything and then allow /dev/null, /dev/0, dev TTY, dev urandom, but prevent all access to actual devices. What if someone exploits SSH or something like that and convinces SSH to make some sysadmin stuff, so mount file systems, remove IP table rules, and things like that? Again, we can avoid that by using capabilities. So capabilities is an effort to break the dichotomy of root, non-root. There are many things in the kernel that are allowed only if UID equals 0, and capabilities is a way to break that down into little bits. So for instance, netadmin will let you change IP addresses, configure network interfaces, set up IP table rules. Netrar will let you sniff traffic and generate random traffic. Problem is that there are some capabilities like capsysadmin. That one is a kind of huge bucket with tons of stuff in it. And unfortunately, like if you want a container to be able to create sub-containers, then you need clone and unshare. And then you need capsysadmin, and then it means that you give the container much more privileges than what you intended to in the first place. So capabilities are not yet perfect. What if someone breaks into the container running syslog, cron, SSH, or something like that, and then they get access to /proc and /sys? because the problem is that /proc and /sys are not perfectly namespaced. Like you could meddle with /proc /keycore. You can do fancy stuff with /proc sys RQ request and halt or reboot the machine or do stuff like that. That's not good. So there are a couple of ways to work around that. One way is to use security modules, so you can prevent the processes in the containers from doing anything unallowed with /proc and /sys, but you would still be able to like look in /proc to see the PIDs and all the debugging stuff that sometimes you want to do there, but you wouldn't be able to tweak and hack things. There is a simple way also, which is to remount those read-only and then drop capsysadmin so people can't immediately remount them read-write, and that also locks out lots of issues. But the real long-term fix is to send patches so that eventually proc and CSFS become completely container aware and don't have those issues at all. Earlier, we mentioned what happens if we find a way to leak out of the container and then suddenly we can, we are UID 1000 and we can hop to another container and be UID 1000. If we run as UID 0, it's even worse because if we hop to a different container or to the host machine, we are root. So the fix is to use the user namespaces that we mentioned earlier to map UID 0 to something else. So even if someone finds a way to break out, well, they are now user nobody on the host, and they're not going to be able to do anything great with that. What about lower level things? So all the startup scripts to set up network interfaces, mount file systems, because we need that. Well, we need that, but not in containers, because in containers, the host will take care of all that stuff. You will never have to do ifconfig or ipedder and all that stuff in a container, because the host will take care of everything on behalf of the container. So that problem doesn't exist, except in a few specific scenarios. Like if you want to do custom file systems with Fuse inside a container, you will be able to execute the mount thing. There are some ways to work around that. Fuse file systems can work in as a non-privileged user as long as you have access to /dev/fuse. And there is another use case that's network appliances, like you want to run Quagga or Bird or some routing daemon in a container and have it set up routes. So the idea here is to isolate the privileged operations. Typically, on the machine, when you want to give access to some root commands to someone, you use sudo, and they can sudo whatever they need to do, but you kind of lock down to a specific command. And here you can do something similar, except you don't even need sudo in the container, because you can, there is a feature with containers that lets you like drop a process inside a running container, and that process can have more privileges. So you need to set up some IP tables rules, and you're like, oh, I want my container to be able to do that, but then it means that I have to give some root permissions to the containers, and we just discussed that it was not a good thing. So the solution is that you run the container normally, and you drop that IP tables process from outside just to set up the IP tables rules that you need, and then that thing is gone. So you don't even have something inside the container able to meddle with IP tables and everything. You do that from outside. So what if you have something that really needs extended access and all those tricks and everything won't work because those things, you want to run them in containers, but they really need to access that stuff? Then we will treat them as kernel level. So what's kernel level? That's like the real code, the drivers talking to the physical hardware. That's like the stacks, the protocol stacks that typically lives in the kernel. And there are like security policies because all this like SE Linux and AppArmor. So if you want to do all those things in containers, even though there are some scenarios where you can still get security, but let's not get into that. If you want to do that, well, do we have to give up? Because the thing is that we are talking about running things that are granted full access on the kernel and on the physical hardware, and we are trying to get them to be safe in containers. That's plain stupid. If something has bus access and access to the full memory of the machine, it's pointless to try to make it secure. It has access to the damn physical memory anyway, so it can do anything it likes. So instead, if we really want security, we give those things their own hardware and their own kernel, which means we run them in virtual machines. And if we want to be a little bit fancy, so let's say you built the whole thing with containers and you say, well, there is one specific thing that sets up routes and uses VPNs and has to talk to the key management interface of the kernel and everything, and I still want to run that in a container because I love containers as a package format to deploy my apps because it's great and yada yada. You don't have to give up on containers if they help you to deploy your software. You can put that container in a VM, for instance, a key VM virtual machine. That's pretty easy to do. And if your like baseline of everything on your infrastructure is containers, then you can put that VM in a container. So I did a little experiment when you run a privileged container in a VM, and that VM runs in a container. So that's sorry, it was either that or Inception, but that guy is funnier. So we started with like the kind of normal stuff with not too many privileges and not too many powers, and we discussed things that required more and more privileges, and at some point we kind of hit the wall, and the conclusion was, okay, if you need really to run that dangerous stuff, run it in VMs. But look at the other end of the spectrum, and let's talk a bit about immutable infrastructure. And actually, let's talk a bit about immutable infrastructure. So why twice immutable? The idea of immutable infrastructure, to kind of summarize in just one sentence, is whenever I need to change a single line of code, I'm going to make a new build, a new image, a new VM image, a new container image, a new whatever image, and deploy that. So each time I'm changing something, even a tiny little thing, I'm bringing up a new server, I'm sending my traffic to the new server, and if everything is fine, I kill the old server. That sounds like a little bit overkill, but it has plenty of advantages. Like if it doesn't work properly, you can roll back instantly to the old server because you still have it around. If you change one line of code like that and it doesn't work anymore, you have to change it back manually, and something could go wrong here. So that's the idea of immutable infrastructure. Immutable infrastructure is about new rule. The server is entirely read-only. So not only it's like a throwaway server because at the next version of your code the server is going to disappear, but the server itself is completely locked down and it's impossible to write anywhere anything. Logs are shipped over the network and all that stuff. We could compromise a little bit and agree that if it's a database, then you can have an area that you can write to, but that area will be mounted no exec. So even if someone finds a way to drop some file here and execute it, well, they won't be able to execute it because that area will be no exec. This makes it even harder for malicious users to break into your systems because a lot of exploits, a lot of things rely on, well, being able to write things. And even if they break into your things, okay, they have access on some server. So if they have enough time, they will be able to try to get access to like database credentials and things like that. But the server itself, it will be virtually impossible to compromise it. They won't be able to set up a rootkit or something like that because they can't write anything anywhere anyway. Okay, so let's recap. Don't run things as root, and that sounds like a basic Unix 101 advice, but that also works for containers. Sometimes we say, oh, I have root in my containers, and it looks like I have some isolation, so I can forget everything I learned during the 10 or 20 or 30 last years in Unix security. No, don't run things as root, period. Drop capabilities, because that helps. Enable user namespaces. That one is a little bit more complex because user namespaces are fairly new. Get rid of those SUID binaries, even though they should be pretty safe, but still, let's stay on the safe side. Enable ECLinux or AppArmor if that's the choice on your distro, but enable that. Use GRSec because that thing, even if you don't know squat about security, ECLinux, GRSec, well, ECLinux helps a lot, but there is a big investment. GRSec, the investment is mostly to look at all the options that you need to enable in the kernel. That takes a while, but at the end, you get a kernel that magically protects you from many things. It's not like completely 100% bulletproof, but it helps a lot, even if you don't know a lot about security. Secure computing, that also helps, but requires some investment. Make sure that you can update your kernels, because if there is something super embarrassing showing up, you don't want to be left in the open or waiting for a way to upgrade your kernels. And if you want to really lock things down, mount everything read-only. Again, it's kind of basic Unix security things, but it also works in containers. And ultimately, if really you have no other choice, you can put things in virtual machines. That's it. Thank you. So just as a reminder, there is another talk about containers this afternoon. Tomorrow morning, we have an office hour in the expo hall if you have any question about containers, security, or Docker. And tomorrow evening, there is, it's truncated at the bottom, but there is a Docker meetup at New Relic. Questions? Yeah.
So your security, I love it, except, well, it fails so much. And you have one word says use your thing, and the next one says you move to your kernel quickly. And I cannot find anything out of it.
Yeah, it's hard to update quickly when you depend on a big patch set like that. In that case, I think it's probably pick one or the other. Actually, I think as I say, the castle analogy is also pretty important. Security is layers, so the more you have, the better you are. And so I think you can pick like, okay, I have a way to quickly roll out a kernel, or I'm using GRSec, and maybe I will only update once in a while. And if you really are super serious about security, maybe you can set up a nice build process so that every single kernel that comes out gets automatically patched with GRSec and tested somewhere. And so if something happens, you know that as soon as the patch is available, you will apply that on top of your source tree and get your kernel out of the door as soon as possible. But of course, that means a bigger investment.
What have you found in GRSec that's worth the trouble that's not in the kernel?
So what have I found in GRSec that really helps? So my experience with GRSec was in the 2.6 line, because in the .cloud days we still are running 2.6.38.2 with tons of custom patches on top of that, including GRSec. And we found that sometimes GRSec will kind of catch something red-handed, and best case scenario, it says, okay, there was something wonky happening in a process and it kills it. And to be honest, I'm investigating exactly what the process was doing was above my skill, but we can guess that either the process was just doing something a little bit weird, or really it was trying to exploit something. And often we would see like the machine starting to misbehave after running things like the Trinity syscall fuzzer, which is something that tries to make completely random bogus syscalls and execute arbitrary opcodes and see what happens. And with the GRSec scenario, the machine would eventually become a little bit unstable, but it would take longer, and we would get tons of kernel messages about GRSec saying, hey, what the hell is going on here, rather than the machine just locking up. So I honestly, I don't know, I couldn't pinpoint one single thing in GRSec that helps. I would think it's more like an array of defenses, like the address space randomization, which means that, when you craft an exploit, you have to figure out the right address to load everything. And if the address space in processes is randomized, it will make the job harder of people trying to exploit that. It doesn't make it really more difficult. I think it got it mainline at some point, yeah. There are a bunch of resources that get reference counted, so that, again, if something weird happens and the reference count goes below 0 or above a given threshold, JRSec will say, what's happening here? And you get an advance warning before everything blows up. There is the fact that a lot of tables of function pointers will be laid out in read-only memory, so that if someone starts to exploit something in the kernel, they won't be able to override those pointers. There is a bunch of little things like that. Other questions? Yeah. So is Docker working on enabling sane security defaults for containers? So yes, we can't yet tick all the boxes. Don't run things as root. Docker will let you run things as root, but I think at some point we might enable big blinking warnings when you end up with running things as root in a container. Dropping capabilities, yes. User namespaces, that's in progress. There's a pull request to do that. No SUID, no, but that would be pretty easy. SC-Linux, yes. SecComp, yes, with the LXC backend, no with the native libcontainers backend. JRSec, well, that's kind of orthogonal to the whole thing. Kernels as well. Read-only mounts, not yet. And VM fencing, kind of. So there was that link to the repository that makes it really super easy to, again, have a container that you would be able to run straight on the machine. Instead, you will run it in a VM, in a container on the machine, and almost transparently. Other questions? Thank you.